Hi everybody, this is problem 4.30. It's one of the problems in your recitations. It was suggested by some of you for a YouTube video. So here it is. All right, this is actually not a very easy problem, but it's a very general physics problem where you have one body accelerating, in this case the truck, and this body is in contact with another body, and we try to figure out what happens. Now, I will say that the reason why this problem is not simple is because they're asking us to place ourselves as the people in the truck who are in a accelerating frame of reference, which is not trivial and is not the best thing to start with in sometimes physics 1. We have some intuition for it, but it's not trivial. Okay, so to understand what's going on, we can think of a few special examples. For example, 1, if the truck surface between the box and it was completely frictionless, then the truck would move with acceleration ax, and the mass will just stay where it is, since it's not feeling any force, and the mass will just drop. Now, from the point of view of the people in the truck, it would look like the mass is sliding back. But for us outside, we're in a real frame. Well, we're in a simple frame of reference, a frame of reference that has a constant velocity, in this case 0 to us. It would look like the mass is just standing still. The car is the one accelerating and just leaving it behind. Another possibility is that the friction between the box and the truck is so large that the mass can actually get pushed with the same acceleration as the car, and then it would look like you just have a static frictional force between the two. But in this case, it looks like the mass is sliding backwards. So it seems that there's some friction, but it's not enough to pull it along with the car. All right, so let's do the body diagrams they're asking for and talk about this even further. All right, for the body diagram of the car, we know that the car propels itself by pushing the ground. And actually, talking about the static friction that tires put on a car is not trivial, to be honest. But it's not the point of this exercise. We'll talk about it later. So we'll just call it the F, the force of the tires on the ground. Or the ground of the tires, whichever. The truck also has a weight and a normal force it feels from the ground. Now, compared to the mass, the truck looks like it's moving to the right. So it's sliding across the mass in this direction. Therefore, the force of friction that the mass puts on the truck must be to the left. So we call this the force of friction K. All right, this was the truck. Now, similarly, we do the box, then we see that sorry, should not have done that. We do the box and we'll get the same two type of forces for the weight, the box, the normal force that the truck puts on the box, and from Newton's third law, you must have a force pushing forward since the box was putting a force pushing back on the truck. Now, since this is the only force in the x, this tells you that the mass is going to have some acceleration in the x. It just will not be as large as the ax of the whole truck. So from the point of from a frame of reference of the people in the truck, it would look like it's sliding backwards. But it's not sliding backwards as fast as if its acceleration was 0, and it would just get left behind very rapidly. All right, so I should warn that one of the easy mistakes to make here is to think that the acceleration of the mass is going to the left, but this is not the case. It just looks that way to the people in the truck because they're the ones accelerating forward. So if anything, the mass is not getting left behind at all because it has some force going to the right. It's just not as big as the AX. All right, I know this is a tough problem. If you're struggling with it, it's okay. But I hope that this was useful.